Hi friends, we're working on the Unit 2, Day 7 notes. Right now we're going to do the examples. Is it possible to prove that lines P and Q are parallel? And then if so, we're going to state the postulate or theorem you would use. And the postulates and theorems are from the previous page. So here we're really checking to see, okay, does the information that they give us with this particular diagram, does it support one of the theorems on the previous page? So we have 4 to choose from, corresponding angles, alternate interior angles, alternate exterior angles, and then same side interior. So the first thing I'm going to figure out is which one you have that's closest to that. So this one right here, I have 58 degrees and 122 degrees. I first need to identify what type of angles these are. So these are same side interior angles. So what I need to do is check, okay, well, do both of these angles, do they add up to be 180 degrees? So off to the side for work here, I'm going to show 58 plus 122. So if I add these up, what I get is 180. So because that these add up to be 180 degrees, those are parallel lines. So lines, is it possible to prove that lines P and Q are parallel? Yes, P is parallel to Q. And then if so, state the postulate or theorem that we used. So we use the converse of the same side interior angles. So converse, so yes, P is parallel to Q because converse of same side interior angles theorem. So now number 2, looking to see what's going on here, it looks like I have this extra angle here, but if I think about this, if I add these two angles together, so I have to do kind of some logic, some kind of deduction here. If I add those two together, so if I add 60 plus 25, that's going to give me 85 degrees. And if I think about that's 85 degrees and that's 85 degrees, that actually matches my alternate interior angles theorem that we talked about previously. So yes, P is parallel to Q because of the alternate interior angles theorem. If your teacher's letting you abbreviate any of these, feel free to use the abbreviations. So then now for this one here, I have these two angles, 82 and 40, and then that's 120. 82 and 40 add up to be 122 degrees. 122 degrees is not the same as 120 degrees, so no, lines P and Q are not parallel. Lines P and Q are not parallel. So that's what that means. Lines P and Q are not parallel. And then now what I'm going to do with this next set is now I'm going to go a different path. Now I want to make the lines parallel. So for these lines to be parallel, I have to follow some sort of idea, rule that we have. So the corresponding angles are congruent, alternate interior, basically the same things from the front, but now I'm forcing X to make these lines parallel. So I want to find what value of X makes these lines parallel. For this one, there is no relationship between this angle and this angle directly. This angle, 100 degrees, has a relationship with this angle here, and this angle here is corresponding to this one. So I know that this angle here also has to be 2 times x degrees. So what I know then is that if I have 2x and 100 degrees, I know that 2x plus 100 has to equal 180. So now I can solve by using our algebraic techniques. So I'm going to subtract 100 from each side. So I get 2x equals 80 divided by 2, and I get x equals 40. Now, because we have the degree symbol here, we don't put a degree symbol with that there. With number 5, these are corresponding angles. So for these lines to be parallel, then these have to be congruent. Congruent means that they are then equal to each other. The measurements are equal to each other. So I'm going to set the measurements equal to one another and then solve. Subtract 1 on each side, and I get 109. So x equals 109. And remember, that's the same as saying 109 equals x. 80 and then x minus 15. These both are same side interior angles. So I can do 80 plus x minus 15 equals 180. So first thing I want to do is simplify on this side, 80 minus 15. So that's going to give me 65. Plus x is equal to 180 minus 65 on both sides. And I get x equals 115. And then now 7, 8, and 9 are the same as 4, 5, and 6, just different types. So for here, I have 4x and then that 6x minus 44 degrees. So these are alternate interior angles. We want them to be congruent, so we're going to set the measurements equal to one another. So I have 4x equals 6x minus 44. A lot of students want to subtract the 6x. I actually think it's easier to subtract the 4x. A lot of students get confused here then. If you subtract 4x from 4x, you're left with nothing. So 0 equals 2x minus 44. And then I can add 44 on both sides. Now, if you solve this a different way, which some of you may have, you would have had negatives, but when you divided at this step here, then you should have ended up with a positive. So x equals 22, or 22 equals x. And again, the types of theorems that we're using, I'm saying at the beginning, like this was alternate interior angles, this is same side consecutive angles, corresponding angles. This one we had to do a few things. I had to make this a corresponding angle and then use our rule, our theorem of line is 180 degrees to get our final answer. These are corresponding angles, so I'm going to set them equal to each other. So 5x plus 23 equals 7x plus 13. So again, I'm going to subtract the coefficient that's smaller with the variable. So I'm going to subtract 5x from both sides. 23 equals 2x plus 13. Minus 13 on both sides. 10 equals 2x. And so then I'm going to divide by 2. I've run out of room though, so I'm going to put it up here. Divide by 2. So I get 5 equals x. And then number 9 here. For this one, this is same side consecutive interior angles. So I've got x plus 20 plus x equals 180 degrees. X plus x is 2x. So I have 2x plus 20 equals 180. Subtract 20 off both sides. 2x equals 160. Divide by 2. And I get x equals 80. Sorry, I kind of cut through that x there. For these last ones here, we're just trying to complete the statement. Sorry, I'm trying to fix my camera too. So here, if two lines are cut by a transversal, so that the alternate interior angles are, and then it gives me an option. So I want to know if they're congruent, supplementary, or complementary. Complementary should be a red flag, because we've not talked about things being complementary, angles being complementary for this. So in fact, complementary is kind of though sometimes you're given an answer on a test, and it's like, that can be that one. This is that case. We haven't even talked about complementary. So we know it's either congruent or supplementary. And I need to remember which one's different. So if I flip back to here, it's same side interior angles are the ones that are supplementary. And this one is alternate interior angles. So we know alternate interior angles, that's talking about things that are congruent. So that would be this one. If two lines are cut by a transversal, so that consecutive interior angles, so consecutive interior angles, that's the one that we're talking about from the front. That's the one that's supplementary. And then if two lines are cut by a transversal, so the corresponding angles, and so we want corresponding angles to be congruent. This finishes the notes for Unit 2, Day 7. Hope you have a wonderful day.